Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guests are from SRC Computers. We have Dave Eaton and Mark Tellez. Gentlemen, welcome to the show today.
Thanks for having us.
Well, thanks for coming on. You know, this is exciting times for SRC. I haven't really heard much from you guys since the old days of Seymour Cray, but I understand you have a new product to tell us about.
Yes, we do. We're going to be announcing at the Velocity Show on the 28th of May the first time that SRC is going to be shipping a high-volume server specifically designed for the commercial server marketplace. So we're very excited about that.
Okay, and up till now, I mean, has SRC been selling software or other things to the public, or is this kind of your coming out event?
Yes, SRC has been selling and installing systems for several defense and intelligence customers of ours for the past 12 years. And we've been selling both the hardware and also what we call Carta, our development software that allows customers to easily write software, write applications for those hardware platforms. So this is the same platform we've been selling for the last 12 years. It's in a form factor that's specifically addressing the needs of the commercial server marketplace.
Okay, and you know, just reading ahead here, it looks like it's very timely type of product, you know, with the energy efficiency in mind. So, with that, why don't we get started here? I've brought your slides up, guys. Why don't we go through that, and then we'll follow it with Q&A.
Well, we're on slide 2. We were founded in 1996, and as I said, we've been installing systems since in the last 12 years. This new computing platform is something we put over $100 million into developing, and we're really excited about our announcement because it'll be the first time that this is available to people that put in thousands of servers in data centers around the country. Slide 3 talks about some of the shifts we've seen in the server market just over the last few years. The biggest thing we see going on is we've kind of hit the limits of what we can get out of the x86 architecture. We're putting in thousands, tens of thousands, or hundreds of thousands of servers, and typically asking them to do a single application all day long. So we're forcing a general purpose computing architecture to do very specific computing. And what's happening is we're just not getting the increases in performance per watt per dollar that we've kind of gotten used to in the 80s and the 90s. And we've got people putting in large data centers that would like to get more computing done with less energy in a smaller amount of space. So that's really what we're addressing. Slide 4 is an actual picture of the product that we're going to be announcing. We call it the Saturn 1 server, and this is designed in concert with Hewlett-Packard. This particular form factor is the first time that an SRC computer will be plugging inside of a Hewlett-Packard chassis. So this fits inside of a Hewlett-Packard Moonshot chassis. And we chose that because the Moonshot chassis has got a passive backplane in it. It's a server chassis that's got all of Hewlett-Packard's features and advantages of lights-out management, but it's processor agnostic. It doesn't care what kind of processor you put in it, and so that allows us to run the SRC server in that chassis. You can see from the slide here, we've got an Intel microprocessor, so you can run Intel-based code on this system, but importantly, it's got an FPGA on it that allows you to run highly parallelized software that you build with the SRC Carta environment run on that FPGA. We've got multiple gigabit Ethernet ports here, 64 gig of RAM on 2 banks, and this processor is capable of replacing many normal servers because of the way we can run the software more efficiently. You could put 40 some of these inside of a single moonshot chassis, and you could put hundreds of servers inside of a single rack.
Hey, Dave, let me just add a point to that. Going back to something that Rich had said at the beginning, one of the things that really makes this particular product stand out for the current customers is the power utilization. This server utilizes only 45 watts total, and even though it's performing the work of many regular standard microprocessor-based servers, it's extremely power efficient because of the way the architecture is set up.
Yeah, good point. So if we want to move on to slide 5, what we've attempted to do in this single slide is really summarize what the effect is when somebody runs an application on the SRC platform versus what they're probably used to in a microprocessor world. The first effect that customers notice is your application runs at exactly the same speed every single time, and we call this a deterministic nature. When you're running an application on an Intel-based system, that x86 environment means your application has to give up the scheduling to an operating system of some kind. And so you get unpredictable performance. You don't really know what resources are going to be available from time to time when you run your application. And that's a big problem for a lot of customers, because if you're running a website, you want that website to respond in a known quantity of time to provide good quality interaction with your customer. On the SRC platform, if it runs at 105 milliseconds response time, it will give you that response time every single time. The next icon talks about the performance. Because you can run multiple instances of your algorithm or your workload inside that single FPGA, every time the clock turns on that processor, you can run hundreds or thousands of instances of your application. And this highly parallel way of running software is something that you simply cannot do in the microprocessor world. If you've got 12 cores, you can run 12 copies of your program. You can turn on hyper-threading and maybe simulate running 24 copies. But on the SRC platform, you could put hundreds of those out there, and every time the clock turns, that many instances of your application actually execute. Now, that highly parallel capability leads to the next icon, which refers to the energy that you use. Because we actually use less wattage per server, and each one of our servers gets more work done, those two elements combine to give you far lower energy use than what we're used to. And of course, that's causing big problems with these big data centers. When you start pulling megawatts of electricity, it limits where you can put these data centers and requires you to put in gigantic cooling systems and big UPS systems. That's less of a problem when you run applications on the SRC platform. And of course, related to that is if I get more work done per server, I can build a much smaller data center. And again, the footprint goes way down, reducing your capital costs even more. And the last icon there is just talking about the fact that an SRC environment allows you to reduce not just your capital expenditure up front, costs you less to build your data center, but to actually own and operate that data center, those operating costs go down as well. Now, the next slide, 6, actually talks about some of the main areas of use cases or workloads that the SRC platform performs quite well on, and I think I'll have Mark go through and kind of describe those 3 different areas.
Sure. Thanks, Dave. So as we've discussed, I mean, really this server platform is applicable to applications where the users have access to their code, where they are typically handling large volumes of data. where predictable latency in predictable response times are important. Some of the areas that we're working with customers in include online transaction processing, so people doing response times to shopping purchase requests, database searches, unstructured database searches in particular are something that we handle extremely well. Financial analytics, things like Black-Scholes, and some of the other algorithms that are used in the financial services market, things like seismic data processing, not something that maybe you think of as a traditional big data application, but certainly fits into that category. Signal processing, something that we've done many years of work in that area because of our history of defense and military work, but again, broadly applicable to areas like image resizing for mobile device, content delivery, for search algorithms, obviously for have image resize requirements, things like Homeland Security, streaming, data processing for any sort of large quantities of data coming across network. Web services, areas that we're specifically are working in include things like fraud detection. We talked a little bit about retail transaction processing, cybersecurity, online advertising and marketing, applications that handle things like content placement, ad placement in real time. Quality of service is particularly important to some of the people working in this area for delivery of content like music applications, things like that. And we support a large number of frameworks for things like streaming computation, so Storm, Hadoop, Memcached, and many others.
Now, all of this high performance, would be kind of a novelty if it wasn't easy for regular developers to access and be able to leverage. And that's why I'm just as excited about Carta, our development environment, as I am about the hardware itself. So Carta is in its 12th version. Our customers have been using this for, as I said, over 12 years in the defense and intelligence area. And it allows somebody to use a high-level language. You can use C, for example, to write software, a single executable that will load out on the SRC server, and we insulate the programmer from having to understand how to manage code that's running on the microprocessor versus code that's running on the FPGA, and how those two different parts of code actually communicate in real time through memory that's shared between those processors. So all of that's done under the covers. You don't have to worry about that as a developer. You just write your code, and Carta loads it onto the server for you. We've got a 3-day workshop that we take customers through, and we usually ask customers to bring their most challenging, hardest to run code with them, and frequently they will actually leave the 3-day workshop with code already migrated over to the SRC platform, running orders of magnitude times faster than it was before. So Carta is something that we're going to be getting people up to speed on so they can leverage the platform. And then slide 8 shows that we're going to be shipping this. Availability will be, as soon as we announce the product, we've got availability right then. It's priced at $19,950 per server. That's a quantity 1 price. And that's another thing I'm very excited about. Previously, to buy an SRC system would cost you hundreds of thousands of dollars. They were uniquely packaged for unique applications. And this one, of course, gives you all that same horsepower, but it's packaged in a way that people can put them into their data centers that they typically would put in a normal 19-inch rack. So those systems can be ordered starting at the Velocity show, and we have a reseller that's certified in configuring and supporting and selling Moonshot BHP chassis, and they've also been trained in how to configure, install, and support the SRC server. So parallelcomputing.solutions.com is where people can go to actually place orders and start installing the SRC system. The next set of slides have content that's actually from one of our pilot customers. So we've had a small number of customers that we gave early access to this server, and they've actually gone through the full experience of running their applications on the SRC platform, and Jingit is one of those. Jingit's a company that has been for some period of time creating software for large retail environment that intersects the transaction of a customer going through a checkout line at a grocery store, at a Best Buy, a Target, a Walmart store, and the interaction between that point of sale system inside the retailer and the branding dollars that are spent by all the brands that are selling products through those retailers. So that's Jingit's world they live in. And slide 10 shows the big challenge that these customers of Jingit put in front of them. And they said when someone goes through the checkout line and all their items have been scanned, as soon as that customer reaches in their wallet and slides their Visa card through, they would like to have Jingit software go out and in the same amount of time it takes to approve that Visa card, which is about 130 milliseconds, to go out and look at the total buying history of that customer and to look at what kind of loyalty incentives they should be giving that customer for that particular transaction. They should also go out and look at all of the in-store specials, all the coupon deals, all the advertising specials that that retailer may be running that would apply to the products that happen to be sitting on the conveyor belt right then. And the third area is they'd like to have the branding specials that are being offered by the brands sold by the retailer that have those specials apply to that customer's transaction. So you can see a lot of complex programs that have to be run, and they have to do that in very, very small amount of time. So that's the big challenge. And to this point, Jingit was unable to meet that challenge. Actually, no one could. And the retailer said, we can't slow down the checkout lane. That's just not an option. So the next slide, 11, shows this is what's going on today all around the world. Is I go in, slide my Visa card through 130 milliseconds or somewhere around there later, it'll come back and tell you that individual's Visa card will either be approved or declined for that particular transaction. The next slide shows what Jingit is able to do now that they've leveraged the SRC platform. While that 130 millisecond transaction is going on and approving the Visa card, they go out and run three very, very complex sets of business rules. One is the loyalty, buying profile history on that consumer. The third set, as I mentioned before, is all the in-store specials that retailer itself is running. And the third business set of business rules are any special deals that are going on with the brand. For example, there's two cases of Diet Coke sitting there that the point-of-sale system just rang up, and Coke might be having that week a 2-for-1 special. So that discount from the brand would actually be discounted directly to the consumer for that particular retailer. Now, what's impressive is that Jingit was able to write all these business transactions and have them execute on the SRC platform in 1/100th of a millisecond. And that delighted the retailers, because what that means is they are not slowing down the transaction time of that customer going through the checkout lane, which is one of the requirements for the application. So if you see the next slide, 13, we've graphically just shown that the amount of time that it takes to approve that Visa card is much, much greater than the total amount of time it takes to run through those 3 sets of complex business logic rules in order to give that customer a better price. So the end effect here is customers can come into these retailers, and instead of paying $65.50 for those items, they get those discounts as being a good, good past customer, discounts that the store, the retailer may offer, and discounts coming in from the brands, and they end up with a lower price, and yet the quality of service stays the same. It doesn't slow down the transaction in the aisle. So that's an example of a use of the SRC platform where a customer was able to offer features and services that were previously just not possible because of the time required.
And Dave, I actually want to jump in there because the timing of this particular interview is actually kind of fortuitous in that Jingit was in our offices in the Springs today doing some work on a deployment system that they have going live. And we had a meeting with them, an all-hands meeting for the employees here. And in that meeting, one of the things that came up was kind of an overview of how they'd progress through this development cycle and some of their thoughts on it. And they freely admitted when we first heard about this system, we had doubts. We heard what you said, and we heard all of the performance claims and latency claims that you were making, but we were skeptical, and it wasn't really until we sat down and we actually came in and we went through the training class and spent a couple of days working on the system that we realized this really changes everything. And so for them, it was very much, hey, we didn't think it was possible, but it's just as good, if not better, than you had said it would be. So I think it's a pretty strong testimonial from a customer who's got a very complex application.
Yeah. So the experience that Jingit had, I think, is a good example, because if I'm offering some kind of service or interaction with customers out on a website, it's really no different. A lot of companies would like to provide more features and enhance that interaction and make it richer. But in order to do that, they have to get more processing done without slowing down the response time. So what we're seeing is very broad applicability of the platform, just in that one area of people wanting to add more features to their application or to their web service without impacting the response time, so they can give their customers more value than they could before.
That's an interesting use case. It sounds like something that, just throwing more x86 hardware at it would not have gotten them to that kind of solution. It still would have had limitations. So it sounds like it's a business enabler to me in this case.
Yeah, in fact, you point out something I think is critical. What Jingit tried to do was they could not get the response time down far enough with a single microprocessor. And so what they did is they took the application and they broke it into chunks and tried to spread it across multiple microprocessors. In fact, they tried spreading it across hundreds of microprocessors.
Mm-hmm.
Well, what they did was, by spreading the application across multiple servers, they introduced additional lag time that made it even worse. So they simply could not break up the problem and spread it across multiple processors, because just breaking it up, in fact, increased the time. So they were really stuck until the SRC platform came along.
Well, I wanted to ask you guys about some of the plumbing here on this. Does this thing run Linux on the Intel side of it, and this is like an accelerator, or how would you describe how the architecture works?
Well, You can boot Linux on the Intel side, but it would be a tremendous mistake to call this an accelerator.
Yeah.
So this is definitely not an accelerator. Again, I can sit down with the Carta environment on my Intel-based laptop,
Yep.
and I can write a single executable, and then I can hit a button and send that executable out to the server, and it will run in a standalone fashion. So an accelerator is typically where you might have an FPGA on a PCIe card, or you might have a GPU separate from my processor. And so I've got another processor that's doing some of my work. I've got the Intel doing some of my work. And those two are what I might call loosely coupled. There's a bus that's sitting in between the two, or there's an operating system sitting between the two. In this situation, it's not an accelerator because the application is actually running on the FPGA standalone. So my FPGA is actually directly connected to those internet connections.
Yeah.
My FPGA actually has direct access to the memory and direct access to the microprocessor. There's no operating system sitting in between. There's no PCIe bus that's interrupting things. And that's one of the reasons we get so much throughput, is there's really nothing there to interrupt things.
Yeah. So the Saturn device is truly a server then, right? Rather than
It's a complete standalone server.
Yeah. Yeah. Interesting.
Rich, it's almost analogous to being able to have a custom ASIC created for each one of the applications you're running at that given moment.
Yeah.
So the software, the application actually becomes the hardware within the system.
So a question I had, guys, was about programmability, right? FPGAs have this reputation for being just tremendously difficult to program, and it sounds like your environment has cracked that nut through this architectural approach. Was that something that took 12 years for it to be fully baked, or how did it come about?
Yeah, you're very, very accurate in your description there. FPGAs have a well-earned reputation of being hard to program.
Yeah.
And the reason is you've typically been forced to use a low-level language, to get that FPGA to do what you want. Even if you're not using a low-level language, there's some other tools out there that let you do things in a higher-level language. However, you still, as a programmer, need to handle and worry about the interaction between that FPGA and what other processors you've got running in that system.
Yeah.
Microsoft, for example, they published a paper last year where they took an FPGA and some memory, put it on a PCIe card, and installed that inside one of their existing two-processor Intel servers. That's not unusual. You see a lot of that out there. Well, in their paper, they explained that it took 16 PhD-level programmers working for Microsoft Research a year and a half to get the Bing algorithm to run on it. That's something that we could do in a few hours with a reasonably competent C programmer on the SRC platform. And the reason is they had to worry about the interaction between that FPGA and talking across the PCIe bus and interacting with their Intel processor. So Carta, as I said before, I think is about as big of an achievement as the hardware it is itself. We have a whole compiler team made up of extremely experienced people that actually came out of the Cray research or Cray company that built this compiler. So it's on its 12th version. So yes, it is a very mature product.
Well, terrific. So I was thinking about how would I know that my application would be a good fit for this, because it's such a different kind of animal.
I think the biggest way to answer that is if you're being forced right now to spread your application out across hundreds or thousands of processors, that right there is an indication that you could use a lot more processing power per server.
Mm-hmm.
So if you're distributing an application across many, many servers, just that fact alone means you're a great candidate for the SRC processor. And that could involve just running transactions through, where you've got, a customer or some input that's causing you to go through some kind of logic and then give some kind of output. Transactions run very, very fast, as we showed you with the Jingit application. And then Mark mentioned earlier that unstructured or semi-structured data, we sift through that extremely quickly. So if you're trying to scan through data coming across some kind of real-time feed, that's another category where we do quite well in.
Some other things that would be good indications are if you're deploying systems that are not being utilized at their full potential. So if you're having to deploy systems that are only being 10% or 20% utilized to maintain a response level to your customer to keep the latency down, that's another indication that there's probably an issue that we could be used to address. Or if you're having to locate your data centers or move your data centers to grow the footprint or to have access to more cost-effective power sources or to put in new cooling systems, and those are all indications that there's probably things that could be benefited from by looking at this technology.
I think it's important to point out, by the way, as far as customer fit, that you're actually writing software or you're migrating existing software onto the SRC platform to gain all these advantages. Mm-hmm. So if I'm a customer that's buying all my software from an OEM and just installing it and configuring it,
yep.
I don't have access to that source code. So in that case, that customer would want to get a hold of who they're getting their software from and ask them to move to the SRC platform. Mm-hmm. So that's an important point to make, because if I'm a customer that's got off-the-shelf software, that means I don't have access to the source code. So to run it through the Carta compiler, you would need to work with your OEM to do that.
Sure. And do you guys have a way to kick the tires on this thing, over the web, or how does one go about doing that?
Yeah, the easiest way to kick the tires is a 3-day workshop that we mentioned, because you can bring code with you, and you will actually get right on a system, mm-hmm. and we take you through Carta, show you how to run Carta, and then we've got applications experts from SRC that will sit elbow to elbow with you and give you advice and show you how to get things working. So that helps people come up the learning curve extremely quickly, and inside that 3-day class, you'll be able to come away saying, yes, this is something we definitely want to move forward on, or we needed to go do some more work.
And I think it's important to stress that 3-day class, both of us have been through it at various times, both by ourselves and with customers we're working with. The first day to day, probably half day even, is really the instruction part of that class. The rest of it is really hands-on and working with, as Dave mentioned, experts here at SRC. So it's not like it's a steep learning curve to get your hands on Carta and start working with it.
Yeah. Well, great, guys. I guess kind of a wrap up here. I just want to ask about the economics of this, right? So, $20,000, and you had customers paying, sounds like 10 times that previously for this kind of capability. For $20K, I could buy a lot of Xeon, right? So, but you were talking about speed ups of 100x. So, do you get into those kind of discussions with customers about how much they could save in terms of power, in terms of everything else?
Yeah, one of the things that we've gotten good at over the years is if somebody gets a hold of us and says, well, here's the type of software, type of application that I'm running, we can typically come back and say, okay, so you're running, I'll bring up an example here. You're running a Black-Scholes algorithm in a financial transaction kind of an application. We know that we'll go, say, 20 times faster with Black-Scholes in one of our SRC systems than a typical 12-core, microprocessor-based server.
Mm-hmm.
So you're going to be replacing several hundred cores there. We can go through and do a very, very tight calculation on what it would cost for them to buy SRC servers versus the Intel servers. So we'd show them the savings in actually purchasing servers, and then we can also do the math and come up with the savings in the electrical cost and the other costs. So we've developed a total cost of ownership model where we type in how many servers they're using today, what kind of speed up they would experience based on actual code, running actual code on our system, and it will ripple through and show them exactly what kind of capital savings and operating expense savings they would receive.
Very cool. Well, guys, I mean, would you say it's fair to say that this is fulfilling the dream that Seymour had for SRC way back in the day?
Oh, definitely. This is, it's been doing, this platform's been doing great work, so far in the defense and intelligence community. What I think is really going to be fun is to see the impact it has in the commercial marketplace.
Yeah.
So, yeah, I think this is definitely going to fulfill the dream he had of having this thing have a wide impact.
Well, that's very exciting. Well, Mark and Dave, I want to thank you both for coming on the show today.
Thank you for having us.
Yep, glad to be here.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.